is being recorded.
Okay, welcome everyone to this week's OMR Architecture meeting. This week we have three topics to discuss. I'm going to depart a little bit from the order in which I have the agenda. I'm going to talk about 2257 first. So I'll get right into that. So 2257 is about applying the consistent use of OS macros throughout the OMR component. If you look at the way, and this really originated from the compiler component and the way that there are a number of uses, many variations of operating system macros that are being used throughout the compiler. And early on in the compiler development, this was before it was actually open sourced, we created a number of sort of standard macros that we wanted to be able to use when we're referring to Linux or Windows or Mac OS, that kind of thing. And we wanted to deploy those throughout, but we never actually did. Since then, I thought that Philip made a good suggestion that we should probably apply this throughout OMR. And then looking throughout the rest of the components in OMR, especially the port library, there seems to be a very wide spectrum of operating system macros that are in use. So what I'd like to propose is that we take, let's say, the ones that we have that we've already got for the compiler, and then make them more general, make them as available as part of a general include that can be used throughout the rest of the code base. So that way, for example, OMR_Linux rather than J9 OS Linux or J9 PowerPC Linux, that kind of thing. So that's one aspect of it. The other is whether or not those OS macros should actually be combined with other architecture macros as well. So, for example, the combining Linux with PowerPC, Linux for PowerPC 64. I like the readability of that, but I'm less sold on the I'm less sold on that. I think maybe just to begin with, let's have a discussion about just the OS macros, the consensus on that, and then kind of go from there. So, anybody have any thoughts on that? All right, done. No.
Is there any inconsistency in how the OS, like are there different OS macros that might be used inconsistently across the code?
So there's a couple of things. So one are the macros that the different build compilers use to distinguish between operating systems. There is some consistency between those, but given the breadth of the compilers that OMR builds with, there are some that don't support all of those. There's actually a sort of a standard list you can find on some page somewhere online that describes for all the compilers, here's what the standard macros are. There are ones that seem to be originating from J9, where but there's nothing really J9 specific about it, right? So that like they use J9 Linux something or J9 Hammer or something like that. So those are like J9 Hammer is basically a synonym for x86 64, right? So so I think undoing some of that as well would provide a bit of clarity. Just before the meeting, Philip was giving me a long list of inconsistent uses of macros that he's come across. So, so to answer your question, there's a little bit of consistency, but not a lot. It's a fairly wide variety.
Well, I know it'll be inconsistent across like compiler component versus other components too, right? So
yes.
You're talking about this across
yes.
the entire project, right?
Yes.
Okay.
Yes.
I think like Ali took a shot at this like in the early days of OMR refactoring, right?
That's where the OMR, that's where the defines.h came from. Yes.
Yep. So has that even spread throughout the compiler component?
No. So this issue was originally created to do that.
Okay. Okay. All right.
spreading.
Yep.
That's
what I remembered. I just wanted to make sure
someone actually came along and took on that PR or took on that issue and did some work for that. And then we decided that this might be worth to go beyond that. So throughout the rest of the code base. So I personally, I think that there's some value in this. The one thing that I think we need to give a little bit of thought to, perhaps, is the effect on downstream projects and how this is going to impact them. I think that, however, I think that if these macros are potentially defined based on, well, no, I don't want to say that. I think I think we will need to look at perhaps one of our major stakeholders, OpenJ9, to see if what the impact is going to be there before we roll this out too broadly.
So presumably OpenJ9 is also using a similarly inconsistent set of pound defines to define things, but we're not initially thinking of eliminating the current set of pound defines. We're just thinking of changing our code base to use a consistent set.
Yes, and our set could be defined in terms of that inconsistent set. That actually makes sense, I think.
So what you're saying is where we would be defining new variables that represent all of the different combinations of things we need or that we think are worth defining in terms of the existing pound defines that are being used across the code base.
What I would hope we could get to is you have OMR Linux, for example, used throughout OMR, yet OMR Linux might be defined based on
some combination of
at least it's all in one place. Yes.
And then OpenJ9 would continue to use until it changed, decided to change, it would continue to use it.
Yes.
Any comments from the non-compiler component people on the phone?
So when we're compiling a lot of the files in OMR, we pass on the command line things like -d J9 hammer. So we're passing the platform on the command line. So I'd also like to get rid of those and just have it all in one file.
So that means those pound defines have leaked into our build system, is what you're saying?
Yes, I think so.
Those defines that Rob is referring to, I think, are only defined on the command line. When I looked through the code, I didn't see any uses of an explicit pound defined J9 hammer, for example. It's injected via the consuming projects via the command line.
So I'd like to see that taken off the command line and put into like OMR config.h or defs.h or whatever this is.
Tend to agree.
What happens for, like, you're trying to cross-compile? What happens in that kind of scenario? Build for a system that you're not currently running on. You still need
if it was in the config.h, you could do it from the configure.
Yeah.
I mean, the other question though is, like, if you're going to do a cross compile, the compiler that you are using necessarily has to define the right set of built-in macros for the target platform. So doing it based off of, like, rather than even doing it in the configure, doing it off of what does this compiler actually say, doing be more consistent, right?
Just for clarity, are we asking about cross-compiling OMR itself or compiling OMR in a cross-compilation for the compiler component configuration?
So I was asking about cross-compiling OMR itself.
Okay.
So is it? It seems to me like something CMake should pass in, or whatever the configurant. Like it's the thing that's typically detecting what the platform is and dealing with what, how you're going to build OMR. Wouldn't that be a more natural place to be defining the OMR?
So it would define OMR Linux.
Something like that, yes. And then that would be, like, it would generate a header file that would be, rather than having a, like, master header file that has some crazy mix of conditional pound if defs thing that someone would have to decode all the time to figure out what the hell's going on. I guess the same logic would probably exist in CMake, so wouldn't that be a more natural way to express that?
It's a more natural place for it.
Right. And then in principle, if that's already been done in the OMR CMake files, it would be more, I guess it's not any different. You can reuse a header file from OMR and OpenJNI too, so it doesn't actually change the amount of work that OpenJNI would have to do to adopt the same scheme if it wanted to. Anyway, it just seems like CMake should be.
Okay, I mean, that's a design point that we can explore as
whether the make system should inject it or whether it should be the compiler that tells you.
Yeah. Yeah. So what do people feel about some of the compound macros that are used? So for example, Linux PPC or J9 ZOS, things like that. I think it is readable, but combinations of those can get out of hand.
We're inconsistent about what combinations we even have already.
Yeah. Okay. I would.
So you're saying, would we rather have an OMR Linux and an OMR PPC, and if you want PPC 64, and if you want the equivalent of Linux PPC 64, you do def OMR Linux and OMR PPC 64, rather than having a single pound define that corresponds to that
Linux
combination.
PPC 64, right? Yeah.
Would it be better to hide that behind a function like macro where you would just name the, like we have a standard list of the names for the OSs and a standard list of the names for the architectures. If you just plug those in, you could build the appropriate and whatever so that if we want to go and change how any of this is factored later on, you don't have to go and do it everywhere in the code base, right? So you just let the preprocessor expand the thing into the appropriate logical expression rather than baking it in everywhere, right? So that you don't have a line that's like God knows how many elements long, right? We just have a.
That is a problem that we have right now, actually. It's very long.
Right. So like you could leave some of the prefixes and stuff off because you could token paste them in. Right? You could just go, test and test environment, N for test, whatever we call it.
Yeah.
Linux, PPC 64, right? And there could even be some other, you could have some variants that have additional parameters for, for still, if you have other aspects.
Host or target even too. Right?
Yeah. It would just make it so that you don't have to remember whatever the mangling convention is, and you're just more declarative. Test host, test target, test, I don't know, both.
It'd be a lot more readable too.
Yeah.
You take out all the verbiage for.
Yeah, you don't have to worry about should I be doing if def or if defined or all that other.
Or pound if.
The pound if, all the other crap that comes up when you're dealing with a C preprocessor.
I'm on board with that.
Some of those function macros would be a little ugly because you'll have to have token pasting and other things to make it work. But
That's just sort of what you get when you work with C macros.
Yeah, yeah, and it kind of hides it in kind of one utility header that hopefully you never have to look at.
Compartmentalize the ugly.
Yes, compartmentalize it, forget about it, lock the door and walk away. I guess we would need to think about the order in which we would want to specify them and what the common queries are that one needs to make and what the convention is.
Okay, so I'll summarize what we've talked about here in the issue itself and probably broaden the scope of it. I know there's a PR. I'll have to sort of see the PR that was open against it already just to sort of see if there's some, hopefully there'll be some code that can be salvaged from that PR still. Is there any other discussion that anybody wants to have on this particular topic?
I think one of the things that I would be concerned about in a lot of the non-compiler code, since we're expecting the platform definitions to come from the command line, sometimes we might be testing what platform we're on before we've included OMR config.h. So if the configuration header is what's specifying what platform we're building for, I don't know. I guess I'm just sort of worried that there might be places where we have to move the configuration header earlier into a file. And I think maybe we should talk about adding it to our coding conventions that at the top of every header, we should be including OMR config instead of putting OMR config in alphabetic order. And then the other thing is we didn't really talk about macros for platform, like 64, 32-bit. So right now we have the OMR env data 64 or env data 32. And maybe it would be good if we could roll that test into the same kind of platform testing framework.
Yeah, I guess part of the issue that where this sort of figuring out all the details happens, it should be identifying what are the set of things that are going to be figured out in this. What are the aspects of the platform? what things are going to be defined this way, and what things aren't going to be defined this way. So, architecture, operating system, fitness seem like three obvious ones.
Endian.
Maybe there are more.
Endianness.
Yes, thank you.
Host or target.
Yeah, host and target.
Yeah. I mean, otherwise, it sounds like a good idea.
Okay. All right. Thanks.
I don't know. I think we may just we may need a few different variants that sort of capture the most common idioms, and then a full one for when you need to really go nuts.
Yeah.
Is 32-bit, or is 32 is 64, or is 32 host is 64 host.
Yeah.
May not even take any actual parameters, but it may map into something like just to decouple all the macros and everything on the back end.
Okay. All right. It was a good discussion. So I'll add some comments to the to that issue. So okay. Next up on the agenda is 4397. Mark, I'm gonna.
Yeah, sure. So I guess this kind of came up with when Matthew opened his issue about sort of extra requirements that hadn't been documented, or dependencies that hadn't been documented that came in as part of the DDR componentry, dwarf, ELF, and zlib, zlib. Yeah, I'm Canadian. Talk to too many Americans. So it just kind of raised his main point was that he got caught by surprise by those build dependencies.
they hadn't been documented anywhere. They weren't part of our documentation for what needed to be installed on the system in order to do a build. And he's right. He was right. But I think there's kind of a larger. So we've taken some steps to try to address the specific issues that Matthew ran into. But I think there's a larger sort of question about how we handle package dependencies as things are added, and then there's kind of and also the question. So there's this document building with CMake that we have, which does talk about a few of the component variables that you use when you're trying to configure OMR to be built. But I don't think that documentation has sufficient detail on what are the available variables that you can use, what are their default settings in OMR, and what are the implications, if there are any, on dependencies when you activate certain components. And so this issue that I opened was around trying to figure out, shouldn't we really be documenting all of that stuff? I don't know if it needs to go into building with CMake or it could be in its own independent document, but it seems like for consumers of the OMR project, this is important information, right? To know what components you need to specify if you want to build it for your use case. And I guess there's also kind of a question that came up in the specific DDR discussion was, what does it mean for a component to be on by default in OMR? Why is anything on by default in OMR if things are disableable? And I think it's a reasonable question. Why force a component on people, or why take anything like why? I guess there's kind of two easy answers. Is, well, just include everything and force people to opt out, which gives people all of the capabilities of OMR from the get-go, but they may not use all of them. Or there's don't build anything and then ask people to explicitly say what it is that they want, be it JIT Builder or GC or DDR, etc. Those are the two most easily consistent answers on what the default is. But I think this is the kind of broader discussion, I think, for the community to think about.
I think that my personal preference is that because we often market this as a toolbox, a toolkit, or whatever, of you just pick and choose the components you want. If you are picking and choosing, you should therefore pick and then enable, as opposed to getting the entire hardware store and then removing sections that you don't want.
I guess there's a separate discussion here, which Keith raised in one of the topics too, is that we want to make sure that we're still testing everything. Even if we were to disable everything, we want to make sure that we're still testing everything.
Yeah.
I think I'd like to consider that a separate issue. Like, that's kind of what flags do we turn on in our pull request testing to make sure that we're not breaking anything versus what's the experience that people get when they try to consume the project.
The other thing is, and perhaps this is part of the documentation, is what are the flags you have to specify, let's say on the CMake command line, to actually enable that component that you want, right? I know that for the compiler test, it's not that obvious that you have to also specify other components, and maybe that's also part of the documentation of the dependencies. So, so having that specified somewhere, if I want this component, these are the things I need to enable. These are the dependencies that it has. Maybe that's a way of describing that. What is on by default right now? Do you know?
I think you get GC by default. You
I
get port.
don't think so. I'll check. I'm checking now.
I'm pretty sure if I don't specify -D OMR GC equals on, I'm pretty sure I will build GC if I just do a make.
Yeah. Okay. So by default, the example is on. DDR is off, FV test is on, port is on, SIG is on, thread is on, compiler and JIT-builder and test compiler are all off, and the GC is on.
Right.
Yeah. Okay, so you're right.
Yeah, so I think that's kind of that's a pretty inconsistent story. I don't think anybody picking up OMR would predict that that's the set of components that they would get by default.
I wanted a port library and I got a GC instead.
Yeah. As well. So I think we need, I mean, I think one of the two defaults, either of the two defaults is probably fine. I think there's been some of the, I confess I like Daryl's argument that if we're arguing at the toolbox, we shouldn't be, putting a hammer and a saw and a screwdriver and a jigsaw and a, crowbar into your hands and asking you to figure out which you need to use, or asking you to use all of them. And so my I think preference would be that the default is you don't get anything if you don't need it. Say what you want. I mean, maybe the baseline components like port. Can you do anything without the port library at this point?
It depends. Well,
Build tool.
So Rob, of that list that you had just off,
yeah,
is it how interdependent are those components? Like, can you enable one of them? Like, can you just flip the switch on any of those, or do they all need each other in some way?
Well, the example needs everything that's enabled to stay enabled. And I guess like because the example is on by default, that's why we've got this weird set of things on by default. GC depends on port depends on thread. Yeah, other than that, you're usually pretty free to enable or disable components as you want. I did write a small utility that can check to make sure that component prerequisites are satisfied. But then we never actually went to go use it because we're looking to look at possibly changing the way that the build system works so that there are no global build flags.
How did that tool know what the dependencies were?
You specified the dependencies. So you would make, the GC requires that the port is on, and the example requires that the GC is on. And then if the user specifies a set of flags that's invalid, then it would error out when CMake is running. It would just tell you about like what dependencies were missing.
So can all of this be specified in CMake, like described in CMake? Like the port library requires thread. I think actually I've seen that code in CMake.
Yeah, you can do things like that.
Therefore, it would add the appropriate -D option to enable all the things that it needs. Is that how it currently behaves?
Well, I guess it depends on how you want it to work. If I enable a component, but then I don't enable its dependencies, do I want that component to automatically enable them? And then can I somehow force the build into a state where it has an invalid configuration? Or I don't know, it depends on how you really want these things to work.
I would think if you enable the component, you'd want its dependencies to be enabled.
Unless that's what I would have said too. I would have thought the best user experience would be if I need GC and GC needs port and thread, then I should only have to specify that I want GC. And then it should tell me that it's also including port and thread because GC depends on them. But
okay.
What am I going to say? No, I don't want port, so the GC will be broken when I configure it. That doesn't make sense. But
and it won't tell you that you're on Linux. You go and do something like that, it goes, you're an idiot. I'm not going to do that. If you really want to do that, compile it from source and do it yourself.
So
if you specifically said I want GC but not port, then it should error out and say, no, you idiot, that doesn't work.
Yeah.
But if you only specify OMR GC, I think it should automatically include port and thread if it depends on them, and then document that that's happening in this
It's
I mean, people shouldn't have to figure out that GC is dependent on port and thread. Like even if there's an error message that comes out that says, "Oh, you dummy, you didn't specify that port and thread were there, and GC depends on port and thread." Like the most natural thing is you'd write that GC depends on port, so then you'll add the port flag, and then you'll say, "Oh, dummy, port needs thread, add thread." And you're like, "All right, fuck this. I'm sorry,
Yeah.
I'm out." Right? So I would think it's just if you need GC, it should enable it, and if you somehow tried to override what the natural dependencies are, you should get
An error.
Yeah, you should get an error explaining.
The
I'm
way
saying
you
you're an idiot, but saying that I can't build the combination that you told me to build because there's a dependency on a component you said not to include.
Yeah, that makes sense to me, and I think it can be done. It's going to add a little bit of complexity to the build system. Somebody has to write that functionality, but I think it can be done. The other thing that I would think about is, for example, like we were talking about, this all started from OMR CUDA. Can a user like actually force a feature of a component on or off? Because right now, how CUDA works is, if you're building port and your platform supports CUDA, then we'll also build the CUDA part of the port library, and you can't really turn it on or off.
So we've been talking about components. I guess the question is whether or not CUDA is CUDA a component of OMR, or is it a?
Well, it's a feature of the port library.
Isn't it like it's like an architecture, like a target architecture? Like when you build CUDA, you're really, for whatever platform, you're really building x86 and CUDA. Right? So surely, rather than being treated as a, it needs to be treated as if it was x86 or PPC or one of these other things, right? Because it's a target for.
Right, but it's also kind of an optional thing, right? Like if I don't want to use CUDA, then why am I carrying around all this code to?
Oh, right. But I mean, if you treat it the same as like an x86 or something, right? Like it's either on or off, and there's a bunch of stuff that's in or out, right?
Right. So it seems to me it's not necessarily a component enablement, a feature flag or something like that. I don't know.
Yeah.
Do we really need to distinguish components from features? I don't know. It's like if they're any different, right? It's kind of, I want DDR, I don't want DDR. I want CUDA, I don't want CUDA. I don't know that we need to distinguish components from features, but I think it should be, I think people should be able to say, I don't want CUDA, and what is our default?
Okay.
I guess that's where the difference might come in, right?
If you want CUDA on?
You're building on a system that has CUDA, and you ask for the port library, because everything needs a port library, then should you have CUDA or not? That's kind of the argument that happened in that issue.
I mean, we can just make it another off by default component.
True. We could do that. It would at least be consistent.
Yeah.
Although, I mean, is it really that much code that we're lugging around? I don't know. Would anybody actually care?
I don't know if you can. I think you need a more consistent rule around that, not grant exceptions on a case-by-case basis, but be more consistent with that. Because someone could come later on with some other feature that they would insist be enabled by default, because it's not that much code.
Well, all right, but so OMR GC equals yes. Does that include all of the different GC policies, or?
I was actually going to ask that.
Because it's kind of the same flavor of question, right?
Yeah. Do you want?
I would say that it's actually a pretty different question, because because the consumer would have to specifically develop support for the garbage collection policy, which involves new glue and changes in the consuming application. So it's not something that can just sort of be enabled without developing support for.
So at least in the case of GC policies, those would be off by default, and a user would have to specifically opt into them, and as a part of that, develop the support for the policy.
Okay, so if I do OMR GC equals yes, what do I get then?
You would get
which is a GC policy. Yeah.
We'll GC only when absolutely necessary, or we'll stop the whole world to do it. If you want something fancier.
You got work.
Yeah, but all that is still controlled through the glue, though, I think, right?
Yeah. I guess the other question, though, is that, like, if you start a new project, yeah, you have to specifically support the different collectors, but are we going to make life for them, like, yes, there will be there may potentially be lots of little hacky projects that people write, but for the big consumers that sort of settle on using the framework, having to tediously go in and make sure that they enable absolutely every configuration that they might want to use. I mean, I could just see something like OpenJ9 having a pretty massive config, whatever, because they have to turn like everything on. Right?
Yeah.
Why don't you sit there for 5 minutes flicking switches on, trying to trying to make sure you don't miss anything.
Okay, well, we could do a -D or everything.
Build it all.
Give me everything.
But then are we going to end up with, mutually conflicting options or whatever?
I mean, on the other hand, the advantage of doing that is that you're, from a J9 perspective, is you know exactly all the different pieces that you're getting. It's not just OMR's giving me some functionality, and I'm just going to trust it.
It actually does give us more flexibility, I guess, to introduce new things that OpenJ9 wouldn't necessarily get by default.
The other side of it is the opposite of the usual TikTok, somebody wrote something cool, I get it for free.
Yeah.
Which is another part of our value proposition. So we're really fighting our own value proposition.
Well, I guess it depends. Like, if there's work that needs to get done to enable it, right, then you might not want to get that for free because it might break you. Right? It's expecting you to provide something. Although I guess avoid that by providing default implementations of things.
I mean,
like that.
It sounds almost philosophical in that it's like we're asking the question, what is the feature now? Because I mean, you could technically take this all the way down to like the optimizations in a compiler and say, oh, we should be able to, and I guess you need a more precise.
Well, I guess the question is, what do we think should be enableable from the? I guess that's kind of the spectrum is what do we think should be enable, disableable at the CMake command line versus what would you implement, for example, an optimizer.cpp file that would pick the strategies that or implement the strategies and the optimizations that you really care about.
Obviously, the optimization is like it's a contrived example.
Yeah, no, I know. No, it's a good example actually because it emphasizes that there is a spectrum there that we may just have to play it.
I think for the purposes of this discussion, we were talking about the major components, right? As opposed to, I think the enabling finer grained is a discussion that we need a lot more thought into, and definitely a separate discussion because there are some gray areas too, like what we just came up with GC there, right? I mean, you turn GC on, but it also needs certain features enabled and. But yeah, maybe that's a discussion we should have at some other time. Unless anybody feels that it's a high enough priority that we need to solve this.
So did we decide that anything that you specify at the CMake level is off by default? Like, should CUDA be off by default, or should it be on by default and you opt into it?
I would agree with that. Yeah.
Keep talking because I still don't know what you mean.
I think everything should be off by default. And I agree with the statement as well that it's a separate story for testing. Right? Like that's a different answer for testing. Testing, yes, we should make sure that any components that we provide are enabled in some way, and then we have tests that run against them.
so they don't go stale.
Although, does Java really want to run all of the JIT builder tests as a part of their testing? Probably
No,
not. They probably don't care.
I think there's a difference between OMR's test config and the test config of a downstream project. They can choose what they turn on as part of their testing.
Right.
When you do OMR test, what do you get?
Yeah. So one other thing that I just want to float out there is that in CMake, it's possible to do a test in OMR to see if OMR is the top level project or if it's a subdirectory of a bigger project. So one thing that we could look at doing is if OMR is the top level project, we could enable the bundled consumers that we have in OMR. So we could say like, okay, we've detected you're building OMR standalone, so we're enabling the example and JIT builder and the test compiler and the FV testing.
So if consumers get that by default, I don't think it's the right approach.
So, but then if you're using OMR as a subdirectory, we would leave everything off by default. So it's just kind of give people a way to download OMR and build it with that.
But do we know that every consumer will put a subdirectory and use it in the context of CMake?
There's no other way to use it.
Well, actually, you could have like a makes file that calls CMake.
Yeah, and then does it know it's in a subdirectory at that point?
No.
Well, you actually, at least, I don't know about the compiler, but see, if you want to enable the GC, you need to provide glue, and the way you provide glue is through CMake. So you still need to write like a CMake wrapper project to install the glue into the GC. So you can't just have a make file to build OMR.
Okay.
So what does OpenJ9 do right now?
CMake.
What?
On every platform?
Sorry, what do you? Oh, if the OpenJ9 CMake build OMR with CMake, and they have glue with CMake.
OpenJ9 doesn't use CMake on all platforms, or even at all in its pull requests right now. So what does UMA?
The old Auto Tools build system.
Right.
Going away.
One day.
Yeah.
Okay. So I'm not convinced that I mean that's not the case for the compiler, right? You can just build JIT builder and then you can just use JIT builder independently. You don't need to. You can just run CMake with an OMR directory wherever, and then take the JIT builder library out of that and consume it.
Yeah.
Right. So I'm not sure we should take that step.
OMR is a standalone project.
Sorry, say that again.
Sorry, you're saying that we just don't look at whether OMR is a standalone project, just leave everything off by default.
Right.
Okay. I'm fine with that.
I guess what's the benefit of having the current packages like the FB test JIT builder by default? Like if we went down that road of having one.
So I guess I just thought that it might be easier for, if we're trying to demo JIT builder to people, it's easier for people to say, download this, run CMake, run the build, and there's no configuration that they need to provide. It just sort of works, and JIT builder is on by default for the people who wanted it, and for the people who are using OMR that way. And then, so I mean, it would just be an easier story for using OMR for people who don't have like a host project.
Do you think that the compromise might be sort of creating a demo config where people, or sort of not a demo config, but like a, I don't know,
CMake-D OMR demo equals on. Something better named than that, but that's the what you mean, right? Like
well, that way you
one
can get
simple flag that would turn on.
Yeah. Well, that way you get what you want, which is everything's off, but
right.
You get it so people can use it relatively easily.
Yeah, that's a good one. That should be pretty easy to do. Right now, we kind of have something like that because we tell people to use the configuration that we're using in our CI. But we could, we could have a configuration that was purpose built to and as like a demo mode, like you said.
Hello, OMR.
Yeah, I think your idea of Daryl's idea of at the component level for now is probably good because it's too complex to go that far, that much deeper. There's already what, like 10 components? Oh,
not that many. Maybe 8 to 10, something like that. Yeah.
I think if those can be switched on and off, or
yeah, we need to figure out the flags for turning them on and off as well.
Then you can have the sub-dependencies afterwards. Like, I mean, with the whole GC needs thread, GC needs port needs thread. I think that's
hopefully we can specify those dependencies by a CMake if they're not already. How that works in a config world, I don't know. Okay. Right. Okay. Did you want to have any more discussion on the?
No, I'm just writing some notes into the issue. What I heard. Figure out how to do intervals.
Spaces. More spaces.
Thank you.
Okay.
Yeah, I think that's. Did we talk about where we should be documenting?
Okay, that's the next topic.
Where the dependencies? Documenting the dependencies for components. Like, should it just be made part of building with CMake? Does anyone have an opinion on that? I don't have a strong opinion on it. So, if building with CMake is the right place to put all that, then there kind of is a section that's sort of like that now. We could just expand on that one, or we could put it in its own document.
I guess the question is, are any of these components that we're needing to build against also runtime dependencies? Because if they are, then there should be a dependencies.md or something saying, if your OMR was built with this support, you require this thing to be available in the environment if we aren't making it optional.
Well, we already have that right now with CUDA. Like if we have to, that dependency should be, and there's also Dwarf and Elf.
Yeah, the CUDA one's just an optional one, right? If it's there, it'll build it. If it's not, it won't build it.
Right.
The issue there was just the message that came out was what kind of suggested there was an error when there really wasn't one.
Yeah.
But the Dwarf, Elf, and
the other one.
Zlib.
Yeah. So, but we already have dependencies that probably should be documented in what you just described.
I guess what I was trying to express was that if the dependency may manifest as a runtime dependency, there should be a top-level markdown file with that list of dependencies and under what circumstances it's required and what the error looks like if you don't have it. And then in the CMake file, anything that's
that's a good point.
Build
those aren't CMake.
Right.
It's not an aspect of CMake. It's an aspect of
OMR.
Creating the build environment for OMR. Yes.
Well, or even the run environment for OMR if you build the demo. And then stuff that's internal to the actual build can be documented in the CMake file if you only need it at compile time, because we'll statically link it or optionally include it at runtime or whatever. Just so that it's easy for somebody who goes and gets hello OMR and runs it. And it was built on a machine with CUDA, and then they put it on a VM that doesn't have it, and it falls over.
Usually in projects, what you'll see is you'll have some section that's called like building. Then it'll list, here are the build dependencies, here are the runtime dependencies, here's the command to build. And then they'll point from there to other documentation files that explain the details of what each option does, etc.
Do we have a document that lists the dependencies?
In there's a README that talks a bit about the build compilers.
Right. And there's a Docker file that I provided at one point, which actually has dwarf in it.
Yeah, I see what you did there.
I believe. Documented.
Thanks for Kuden.
Air quotes for the people on the phone there. Around documented.
Is that Docker file still in OMR?
I used it
Where is
recently. In the build end.
That's every day. I think it's inside
Docker. Yeah,
there's
even a, so I did that to make it easier for when something fails. It doesn't have. Oh, yes, it does. Anyway, if you have a test failure on, say, Linux, and you work on, say, Mac OS, because you don't have a Linux box, recreating that environment from scratch to run that test and duplicate the failure is not always easy. So I created that Docker container which has a do build in it, so it'll just pop up, do a build, and then it'll sit there and wait. You can do whatever you want at that point. Anyway,
all right.
It makes it easier to reproduce problems when it's not your.
Any more discussion on that particular topic? Move on.
Although it does a bare CMake. It does this, actually, this is a CMake command that I believe our pull request. It does dash dev uses the cached CMake.
Okay. So the last topic, a comment in another issue where Mark,
The release issue.
Asked about where we should be documenting our API of the components that are API stable.
Right. So someone made a very, Abhinav made a very natural, had a very natural question once we declare these three components as API stable. So where is the documentation for this stable API that you've announced? Which was an aha moment, of course. And so I went and asked Rob, and Rob helped, sort of track down where I knew there was documentation in a bunch of the header files and some of the implementation files, but it's kind of spread out and spread throughout the components that are there. So I think we should probably spend some time trying to collect together. Some of the documentation is not very complete either. Like there are Doxygen comments in there where it documents a parameter by specifying its name, and that's the documentation for the parameter. So that's not ideal, even though in most cases it's pretty easy to reason about what that parameter is. We should probably do better than that. So I think ahead of the next release, whenever that is, and that's, I guess, a topic for the next one of these meetings, I think, I think we should try hard to collect together the API documentation for port, thread, and util, and try to put that somewhere so that we can point people at the API that we're keeping stable.
Okay.
So I don't know what we can discuss that now if people disagree with that statement, but I'll have a hard time not believing that we should document our stable API components.
Yeah.
The main question, I guess, is who's going to do that? And I don't think we're going to have a release in the next 2 weeks, so it's not like urgent that we do this. I think our next release is likely to be, at least a month or two away, at least. But we have to discuss that, but I think we do need to schedule this work somehow.
Should we consider also running Doxygen and actually posting the documentation somewhere?
Looking what it generates right now?
Yeah.
Yeah.
That would be a good start.
Because there's a lot of oxygen comments in there, but I don't know how recently anybody checked that they actually gen properly.
Or how consumable the output is. Right, and
what it looks like. I certainly know there's some ASCII art in at least one of them, so that's probably got a red nerve or other reviews.
I know there are parts of the JIT Builder API that we've tried to be more rigorous about providing Doxygen comments on, but it's still not complete. Like, there are lots of them that don't have.
Well, we are insisting, we should be insisting, at least in the compiler component, that any new API that gets added has a Doxygen comment for it, and I think we've been pretty good at that. And even people that have changed existing APIs have sometimes convinced to add a Doxygen comment. So, very good. I think that, yeah, I mean, in terms of documenting the API, I mean, I think it might, like at some point, the compiler is going to become an API stable, whatever that means. But I think that whatever that means might be influenced by how, like, we need to think about how we're actually going to expose the API to the compiler, right? And I don't know if you've actually quite done that yet. But
we haven't thought about it, or we haven't.
A bit of everything. Like it's more than just the three methods that we've talked about in the past, right? We have a much wider surface area than that. Maybe we shouldn't, I don't know. But I can't remember the point I was trying to make. But
more to do.
Yes. So what did you want done for by the next meeting?
By the next meeting. No, I don't want to. We don't have to do anything for the next meeting, but
the next release.
Well, we need to discuss what we're going to do about releases going forward, right? So we just put out 0.1.0 as kind of stake in the ground. Kind of here's where we are. I think we need to have a discussion around how are we going to do releases going forward? Are we going to time box them? Are we going to choose a set of features that we think are important enough to warrant a release? What kind of frequency are we going to target if we're doing the second one of those? Kind of how do we imagine scheduling and targeting work for these releases going forward? So, kind of topics like that, and then anything else anybody wants to talk about.
Okay, we can do that.
Releases.
We can talk about that next time.
I think it's something we need to wrestle to the ground, that topic, so that we can just start moving forward on it, figure out what we're doing.
Okay. That might be the only topic then. Unless there's
could be a good discussion.
Okay.
I certainly have thoughts on how we should do it, but I really like to hear what other people think.
Did you want to create an issue for that so that people can land comments before?
We don't want our issue camp getting too low.
Yeah. Have it drop below 542.
Is it where we are?
Okay. Which is probably another longer term discussion point that we should around curation of our issues and pull requests and so on. But we don't have to discuss that today.
Okay. All right. Any other discussion on that particular point? If not, then we've reached the end of our agenda, and I guess we'll convene again in 2 weeks. So, thanks, everyone. Bye.